world of finance, activation function play a crucial role in shaping the output of machine learning models. Understanding these functions is essential for making informed investment decisions, optimizing portfolios, and accessing credit worthiness. In this video, we'll delve into the world of activation function and their types, that is ReLU, Sigmoid, Softmax, Hyperbolic, Tangent, Swish, and Linear, providing simple explanation and practical real-life applications from the finance domain. So let's get started with understanding what is an activation function. In machine learning, an activation function is a mathematical operation that determines the output of a neural network based on the input it receives. It is used in the activation layer of the neural network, which processes the input and produces the output. In simple terms, it is like a switch that turns on or off, or a valve that regulates the flow of information in a complex system. A practical example from the finance domain could be a credit scoring model. So in this, the activation function could be used to determine whether a loan applicant is considered a good or bad credit risk. So here the inputs would be various factors such as the applicant's credit history, income, employment history, etc. And then the activation function would use these inputs to determine the probability of the applicant defaulting on the loan. So if the probability is above a certain threshold, the applicant would be considered a good credit risk and the loan would be approved. But if the probability is below the threshold, the applicant would be considered a bad credit risk and the loan would be denied. So in this example, the activation function acts as a gatekeeper, determining whether the loan application is approved or denied based on the set of criteria. It is a simple yet powerful tool that helps financial institutions making more informed lending decisions. Next comes the types of activation function. First is ReLU or rectified linear unit. Now this ReLU is a type of activation function commonly used in deep neural network. It is a simple yet effective function that helps improve the performance of neural network by adding non-linearity to the model. So in simple terms, ReLU is a mathematical function that takes a number and either outputs the number if it is positive or outputs 0 if it is negative. So the practical example of ReLU activation function in the finance domain is a fraud detection system. So in this case, the input to the ReLU function would be various features of the financial transaction, such as the amount, the type of transaction, the location, etc. So the ReLU function would process these inputs and produce a binary output, that is either 1 indicating the transaction is fraudulent or 0 indicating the transaction is legitimate. So here this ReLU activation function works by turning off or ignoring negative inputs, which can help the model focus on important features that are positively correlated with the outcome. So in the case of fraud detection, this means the model is able to focus on transactions that are significantly different from normal transactions and are more likely to be fraudulent. So by using this ReLU activation function, fraud detection system can make more accurate prediction, which can help financial institutions detect and prevent fraudulent activities, reducing financial losses and improving customer trust and satisfaction. Next comes sigmoid activation function. Now this sigmoid activation function is a mathematical function that maps any real number to a value between 0 and 1. It is often used in neural networks as it helps to reduce or introduce non-linearity in the model, allowing it to model complex relations between the inputs and outputs. So in simple terms, a sigmoid function can be thought of as a squishing function that takes a number and squeezes it in the value of 0 and 1. A practical example of sigmoid activation function in the finance domain could be in the credit scoring model. So in this case, the sigmoid function would be used to determine the probability of loan applicant defaulting on their loan. So here the inputs to the sigmoid function would be various factors such as the applicant's credit history, income, employment history, etc. Then the sigmoid function would use these inputs to produce a probability between 0 and 1, indicating the likelihood of the applicant defaulting on the loan. So the sigmoid function is well suited for this task because it can output a probability value, which is a value between 0 and 1, and this allows a credit scoring model to make more informed decision about whether to approve a loan application or not. For example, if the probability of default is above a certain threshold, say 0.5, the loan could be approved, while if it is below the threshold, the loan could be denied. So by using a sigmoid activation function, the credit scoring model can provide financial institutions with a clear and intuitive measure of credit worthiness, helping them make informed lending decisions and reducing the risk of default. Next comes softmax activation function. Now this softmax activation function is a mathematical function that takes in the vector of arbitrarily real values and squishes them into the vector of values between 0 and 1 with the sum of values equaling 1. It is used in neural network for multi-class classification problem where the goal is to predict one of the multiple possible classes. In simple terms, the softmax function can be thought of as a normalizing function that takes a set of numbers and spreads them out so that they sum up to 1. A practical example of softmax activation function in the finance domain could be in a stock market prediction model. So in this case, the softmax function would be used to predict the likelihood of a stock price moving in one of the several possible directions, say up, down, or staying the same. So here the inputs to a softmax function would be various technical indicators such as the stock's historical price movement, volume and trading activity. So the softmax function would use these inputs to produce a vector of probabilities indicating the likelihood of stock price moving in each of these possible directions. The softmax function is well suited for this task because it can output a vector of probabilities which can be interpreted as the likelihood of each possible outcome. And this allows the stock market prediction model to provide investors with a clear and intuitive measure of the likelihood of different stock price movements, helping them making informed investment decisions. So by using a softmax activation function, the stock market prediction model can provide investors with a more accurate and reliable prediction of stock market movements, helping them to make informed decisions and potentially reduce their investment risk. Next comes hyperbolic tangent activation function. Now this hyperbolic tangent activation function is a mathematical function that maps any real number to a value between -1 and 1. And it is often used in neural network because it helps in introducing non-linearity in the model, allowing it to model complex relation between the inputs and outputs. So in simple terms, this 10h function can be thought of as a squishing function that takes into the number, squeeze it into the value between -1 and 1. And the practical example of 10h activation function in the finance domain could be in the credit rating model. So in this case, the 10h function would be used to determine the credit rating of a borrower. The inputs to the 10h function would be various factors such as the borrower's credit history, income, employment history. And then the 10h function would use these inputs to produce a value between -1 and 1, indicating the credit worthiness of the borrower. And the 10h function is also well suited for this task because it can output a value between -1 and 1, which can be interpreted as a measure of credit worthiness. For example, a value close to 1 would indicate a highly credit worthy borrower, while a value close to -1 would indicate a borrower with poor credit history. So by using this 10h activation function, the credit rating model can provide financial institutions with a clear and intuitive measure of credit worthiness, helping them make informed lending decisions and reducing the risk of default. Additionally, the range of -1 to 1 allows for a more nuanced representation of credit worthiness, providing a more accurate picture of the borrower's financial situation. Next comes Swish activation function. Now the Swish activation function is relatively new activation function in the field of deep learning. It is a combination of ReLU activation function and a scalar value from this 10h, that is a hyperbolic tangent function. So the Swish function would be x into sigmoid kx, where k is a learnable scalar parameter. So in simple terms, the Swish function can be thought of as a modified version of ReLU function that introduces soft gating mechanism. It takes in a value multiplied by a gate value, that is the output of sigmoid and 10h function, and produce an output between 0 and input value. The practical example of the Swish activation function in the finance domain could be in the stock price prediction model. So in this case, the Swish function would be used to predict the future price of the stock. So the inputs to the Swish function would be the various technical indicators such as the stock's historical price movements, volume and trading activity. And then the Swish function would use these inputs to produce a value between the 0 and input values, which can be interpreted as the predicted stock price. And we know that the Swish function is well suited for this task because it combines the strength of ReLU and 10h function. The ReLU function is computationally efficient because it helps to introduce non-linearity in the model, while this 10H function introduces a gate mechanism that can control the influence of each input on the output. And this combination allows the stock price prediction model to learn complex relations between the inputs and outputs and provide accurate predictions of future stock prices. So by using the Swish activation function, the stock price prediction model can provide investors with more accurate and reliable predictions of stock prices, helping them make informed investment decisions and potentially reduce their investment risk. Next comes linear activation function. Now this linear activation function, also known as identity function, is a simple mathematical operation that returns its input unchanged. It is defined as fx is equals to x. So in simple terms, the linear activation function is a function that does not alter the input in any way. It simply passes the input through it without modifying it. And a practical example of the linear activation function in the finance domain could be in the portfolio optimization model. So in this case, the linear function would be used to determine the optimal weights to allocate to various assets in the portfolio. The inputs to the linear function would be the expected returns, the volatility, and the correlation of the assets. And this linear function would use these inputs to produce a set of weights which can be interpreted as the optimal allocation of the portfolio. And the linear function is well suited for this task because it allows a portfolio optimization model to learn the linear relations between the inputs, that is the asset returns, volatility, and correlation, and this output, that is the optimal portfolio weights. And this helps the model to efficiently allocate the portfolio assets and achieve the desired risk return trade-off. So by using this linear activation function, the portfolio optimization model can provide investors with a clear and intuitive set of optimal portfolio weights, helping them make informed investment decisions and potentially improve the overall performance of their portfolio. Additionally, this linear function simplicity ensures that model is computationally efficient and easy to interpret. Thank you.